A couple of videos back, I created Plant Monitor V1. While the device worked, it was far from perfect and had its own drawbacks. It was very large and needed to be near an outlet at all times in order to work. The form factor took too much away from the plants and made it visually unappealing. This is why I wanted to create a better and more useful version of that project. The new device is centered around the ESP32C3 from Seed Studio. Its tiny form factor and integrated battery charger made it an easy choice. To design the PCB, I used KiCad, which is a very well-known and popular PCB design software. I tried to design the PCB to be as small as possible while also being relatively easy to assemble. The board has 3 LEDs which will be used to indicate the levels of battery. On the top of the board there is a connector for the 200 mAh battery so I can easily remove it if I need to. There are 3 resistors for the LEDs and 2 more that connect to the ESP32 so I can read the battery voltage. After I was pretty happy with the design, I exported the Gerbers and sent them to be printed. This also brings me to this video's sponsor, PCBWay. PCBWay is an easy-to-use, trusted, and affordable PCB manufacturer. Using their online tool, you can quickly upload your Gerber files and choose from a variety of materials and finishes for your PCB. Alongside PCB manufacturing, they also offer PCB assembly, CNC machining, and 3D printing. Check them out in the link below to learn more. After a bit of waiting, the PCBs arrived. I was very impressed with the quality of the board and how the black solder mask finish looked. I started by first soldering the ESP32 to the top of the PCB. I also had to desolder the existing pins on the soil moisture sensor. When I finished soldering and went to test out the board, it wouldn't work. After some troubleshooting, I narrowed it down to the battery, which wasn't making contact with the board. The problem was with the PCB. The battery pads were extremely difficult to solder because they were underneath the ESP32. After some research, I found that changing them to holes instead of pads should solve the issue and let me solder them from the back of the board. After a couple other minor changes, I came up with this. With the new redesigned PCB, I soldered the ESP32 once again, this time with much better success. While I was troubleshooting the PCB, I found that many people recommend to use a clothespin to better hold the board while soldering. Successfully soldering the battery pads, I soldered the rest of the parts into place. There are 2 220K resistors for reading the battery voltage and 3 220 ohm resistors for controlling the LEDs. I changed the LEDs to be different colors so the battery capacity is easier to read. After I finished soldering the board, I flashed it with ESP Home and checked to make sure that the LEDs and battery were working. I then added it to Home Assistant. Here is the ESP Home code that I used for the device. Depending on your moisture sensor, you might need to change some values to reflect what is wet and dry. Since the components didn't look very pretty by themselves, I went to design a case for them. I kept the design very similar to the first versions, except I made everything a bit less tall and a little less wide. I printed the case in matte black PLA to better camouflage it with the soil. To assemble the parts in the case, I used 4 M3 bolts along with some M3 nuts to keep the board sturdy and secure. While they were slightly tricky to position, I eventually got all 4 in place. I finished the project by plugging in the battery and closing the lid. Overall, I'm really happy with how the project looks. Comparing it to version 1, the difference is seen in almost every aspect. The device is much smaller, more powerful, and more convenient because of its battery. It's also much more power efficient thanks to Arduino's deep sleep mode, which puts the ESP32 into an extremely low power mode when it's not sending information. With everything finished, I decided to give it a test. When installed in a large plant, the device is almost invisible, and very few people will know it's there. Using the Home Assistant app, you can view the soil moisture level as a percentage and on a graph. You can also see the battery voltage. I also set up notifications for things like the battery so that I remember to charge it. Charging is also super easy thanks to the integrated USB-C port and LEDs. Home Assistant then sends a notification when the battery has been above 4 volts for 2 hours. In the end, I had a lot of fun improving my previous project and will definitely be making good use of it. You can find the parts and 3D model in the description below. If you enjoyed, make sure you subscribe and also don't forget to check out PCB Way in the link below.